Hello, and welcome to part three of our force and motion unit. Today, we're going to talk about motion and speed. So, to start off, we're going to talk about what is motion. Now, when things move, we say there's motion, right? Okay. And in this picture, you see a pitcher doing a windup and pitching to home plate. All right. So, we just said that motion is movement. Okay. But how do we tell that something is moving? Well, to understand motion, we have to look at an object's position. Now, position is the location of an object in relation to another nearby object. Okay. We can only figure out the position by looking at the frame of reference. Now, the frame of reference is something to compare the object in motion to. Now, in this case, what we have is we have the pitcher here, right? And we think that he's moving because this is three shots laid over each other. So he's starting out right here, winding up, and moving all the way down here. But how do we know that? Okay, because if this was a black background, we couldn't tell that he's moving. Our frame of reference, we can use a couple different ones here. We can use the bases on the bottom right hand corner. And you see in the first picture with his leg up, he's far left of the bases, all the way going to the last picture that's in this thing. And his left leg is forward. In fact, it's in front of the bases at this point. So we can use the first base as a frame of reference. Now, most people assume the word motion with the word moving, and that's correct. So, what we do is we define motion as a change in position. And like we said, the picture here is changing position. How do we know that? Because we're looking at that frame of reference. And you can have multiple frames of references too. You can do the rubber that he's pushing off of to pitch, or if there's something that looks like there's a sign that's kind of blurry behind him, but you could use that sign behind him. So you can have multiple frames of reference to help you figure out if something is in motion. Okay. Now, what is speed? Speed is something that measures how fast something is going. Okay. So, for example, some things go really fast, like a Ferrari. Some things go really slow, like a snail. Okay. So, we define speed as the change in position of an object over a certain unit of time and distance. So time could be seconds, could be hours, could be whatever. Okay. Distance could be centimeters, could be inches, could be feet, could be miles. It all depends on what you're talking about. So in this picture here, we have a DeLorean. This is a scene from Back to the Future. We have the DeLorean, and you guys know that a car is usually measured in miles per hour because we can talk about how far a car can go, how many miles it can go in 1 hour. Now, if we're talking about a snail, using miles per hour is not going to be something that's going to be smart. Why? Because the snail's really slow. So instead, we can talk about feet maybe per hour, or we could do inches per minute, something like that. We've got to adjust it to how fast the object is going. Okay, now here's a little video to how to figure out speed mathematically.
Which travels faster, Usain Bolt or a Formula One car? In this video, we'll find out how to calculate speed using distance and time, which we'll then use to work out the answer to who's faster. Speed is a measure of the distance an object travels in a certain time. Speed can be calculated using the formula speed equals distance travelled divided by time. So, to work out which is faster, Usain Bolt or the F1 car, we need to know how far they both travelled and how long it takes them to cover that distance. Let's work out the speed of Usain Bolt first. In 2009, Usain Bolt set the world record for the 100-metre sprint in 9.58 seconds. The distance was 100 metres. The time taken was 9.58 seconds. Using the formula of speed equals distance divided by time, 100 metres divided by 9.58 seconds means his speed was 10.44 metres per second. We have the units for distance and time, metres and seconds, which we use to work out the units for the speed. Metres divided by seconds, which we say as metres per second. That's pretty impressive, even for the fastest man on Earth. So how fast is an F1 car for us to compare him to? Pause the video and work it out. Did you get 375 kilometers per hour? So who's faster? From these speeds, we can't tell. What's the problem with comparing these two answers? Pause the video and have a think. To work out which is travelling faster, the units of speed must be the same. So let's convert the Formula 1 speed also into meters per second. Kilometers into meters multiplied by 1,000. And turn 1 hour into seconds by multiplying by 60 for minutes and then 60 again for seconds. So 375,000 meters divided by 3,600 seconds gives us 104.2 meters per second. Now we have our speeds in the same units, it's easy to see that the Formula 1 car is much, much faster. The formula can also be written in a formula triangle. Speed equals distance divided by time. Time equals distance divided by speed. And distance equals speed multiplied by time. Here are 2 questions for you to do. Pause the video and work them out. Did you get them right? A distance of 150 kilometers and a time of 1.66 hours, which is 1 hour 40 minutes. So now you can calculate speed, distance and time and understand a little bit about the units of speed. And of course have proved that a Formula 1 car is faster than even the fastest person on the planet.
Okay, now we're looking at that triangle then, the speed, distance, time triangle. So if you were to cover up the word distance, if we wanted to figure out distance, we're going to use speed multiplied by time. If we cover up the word time, if that's what we're trying to figure out, you're going to have distance divided by speed. And if you're trying to figure out speed, the equation for speed is distance divided by time. Now it's very important to always remember to label your units of measurement. If I said I ran 7, well, what does that mean? 7 miles per hour? Could it be 7 inches per minute, which is more my speed? You've got to make sure you have the proper labels when you're measuring speed, okay? Let's do a couple problems here. To figure out speed, we use evenly spaced units of measurements. Think of a highway mile marker. Those are evenly spaced units since they are posted every single mile. From there, we would time how long it took for a car to go from 1 mile marker to the next. So let's say we started a stopwatch when a car started to move at mile marker 0, and we stopped it at mile marker 10. Our stopwatch said that it took 5 minutes. We're simply going to divide the distance, which is 10 miles, by the time, which is 5 minutes. Okay, so we go 10 miles divided by 5 minutes, and we wind up we're driving 2 miles per minute. Okay, here's a couple other questions here. Our question, I ran 35 miles in 7 hours. What was my speed? Well, let's look at the information that we have. The distance we're talking about is 35 miles. The time we're talking about is 7 hours. The equation we're going to use since we're trying to figure out speed is 35 miles divided by 7 hours. Now 35 divided by 7, as you guys know, is 5. So our speed is going to be 5 miles per hour. Let's look at one more question. It says in 6 hours, a snail sludged 48 centimeters. What was the snail's speed? So the distance now is 48 centimeters. The time is 6 hours. Our equation, distance divided by time. So 48 divided by 6. So our final speed is going to be 8 centimeters per hour. Okay. Now, you're going to stop right here, go to the Force and Motion Part 3 assignment in your Google Classroom, and you can answer the questions about that lesson.